Alright, today we'll be studying series wiring. There are many circuits in which more than one device is connected to a voltage source. In other words, we have more than just like one light bulb. If they're connected in such a manner that there's only one current path, then it's called a series circuit. So in this case, there's only one current path. It leaves the battery, goes through R1, R2, and then back again. And since there's only one current path, if one of the devices go out, like let's say this one goes out, then no current will flow and they'll both go out. What I'd like to do now is derive an equation for how to add resistors in series. Alright, since there's only one current path, the total voltage drop across the battery must be equal to the individual voltage drops across each resistor. So the voltage drop across this plus the voltage drop across this has to equal the total voltage drop. And from Ohm's law, we can replace voltage with IR. So I can replace V1 with I times R1 plus I times R2. And since the current's the same for both, I can factor it out. So, how do you add resistors in series? Well, you just basically add them together. R1 plus R2 plus R3 plus R4. So let's try an example. We have a 6 ohm and a 3 ohm resistor attached to a 12 volt battery. What I'd like to know is what the current, the power dissipated in each resistor, the total power delivered to the resistor by the battery. Alright, so the first thing we're going to do is try to find the equivalent resistance. So since it's a series circuit, all we do is add the two resistors together. 6 ohms plus 3 ohms is 9 ohms. So here's our equivalent resistance, or equivalent series circuit, in other words. To find the current, we just use Ohm's law. And this will be the total current for the whole circuit. So you take 12 volts divided by the equivalent resistance, it's 1.33 amps. Now this will be the same current that goes through this resistor and this resistor because there's only one current path. Now to find the power, we know that power is equal to I squared R. I is the same for both of them. R is different for each of them. As a matter of fact, this is twice the resistance of this, so it ends up using twice the power. And to find the total power, we just add them together. So as you can see, series circuits are pretty simple to understand.